Students, let's see how we do with this problem. As I promised, I will record a 3x3 system, an example of a 3x3 system. Let's see how it goes. Anyway, this is an application, typical, the one that we see all the time. John invested $12,000 in 3 different funds. Fund A, money market, with a yield of 3% annually. Just call this guy A. B, municipal funds at earning 4% annually. Last but not least, option C, mutual fund 7% annual. What do we know? He invested $4,000 more in mutual funds than in municipal funds. So he invested $4,000 more in C than in B. And the total interest earned in 1 year was $670. And the question is, of course, how much did he invest in each type of fund? Okay, so first of all, he invested $12,000. So A plus B plus C equals $12,000. That's how much money he deposited. Now he earned $670. How did he get this money? Well, he got 3% of whatever he invested in A plus 4% in B plus 7% of whatever he invested in C. In other words, 0.03 in decimal, obviously. A plus 0.04 B plus 0.07 C equals 670. And of course, we need 3 equations since we have 3 unknowns, minimum 3 equations. So we get it from here, $4,000 more in one than the other. So the investment in mutual funds, namely in C, equals 4,000 plus whatever he invested in municipal fund, which is B. So whatever he invested in mutual funds is $4,000 more than what he invested in municipal fund. So C equals 4,000 plus B. So let's write this one in standard form, namely all the A's, B's, and C's line up. So this is what we, and also I'm going to take care of the decimal. Notice, folks, that I have 2 spaces. I'm going to multiply this one by 100. So we can move the decimal place 2 to the right. So we have A plus B plus C equals 12,000. 3A plus 4B plus 7C equals 670. And here I'm going to subtract B. So negative B plus C equals 4,000. And that's our system of equation 3 by 3. Now we need to solve it. Let's take a quick parenthesis here. So this is our system, something that we didn't do in class. I didn't want to do it, but let's go ahead and introduce the concept of matrix without going too much in detail. But we're going to extract the coefficients and work with just the coefficients. Let's ignore the variables, only with the coefficient using matrices. The matrix, of course, is an array. So each row will represent an equation. Each column represents a variable. Now we're going to augment it with the right-hand side. So let's go ahead and do that. Once we get the matrix, the whole idea will be, well, let me just first put the matrix with 1, 1, 1. Those are the 3 coefficients, and it's augmented with the value 12,000. So we just do this dotted line, and we write down the right-hand side here. The next row will be 3, 4, 7, 6,700. 3, 4, 7, 6, 7, 1, 2, 3. And the last one will be 0, because I don't have anything here. Negative 1, 1 and is 4,000. We just do this. This is our matrix. It's a 3x3 system, 3 rows, 3 columns, and it's augmented by the right-hand side. Okay, this is -1. Now, the whole idea is to work with this matrix and do a bunch of arithmetic operations or matrix operations. So we end up with the following: 1, a number, 0, 1, a number, 0, 0, a number. I mean 1, and it's of course augmented to the right-hand side. Notice all that the goal would be to have on the diagonal a bunch of 1s and be under the diagonal 0s, and that would be the goal. Let me erase so I can have more space. Before I erase everything, notice folks, this is what we are trying to get: 1 and a bunch of zeros under the 1 and not 0, and then the 1. We can always flip the rows. So I took advantage that I already have a 0. So I made this one row number 2, 0, -1, 4,000. And row number 3 will be 3, 4, 7, 6,700. Now I can erase. And we need to remember the goal would be to have 1, 0, 0. I need to get rid of this 3. And the only thing we can do is multiplying by a number and add it to the particular row. So this matrix, and now this becomes 1, 1, 1, 12,000. This is good. We already have the 0, -1, 1, 4,000. Now I need 0 here. I have 3. So what are we going to do? We are going to take row 1. We're going to multiply it by -3. And we're going to add it to row number 3. In other words, -3 times R1 plus R3. This is when it gets a little bit painful, so let's go ahead and do it. -3 times 1, -3 plus 3, voila, 0. -3 times 1, -3 plus 4, 1. -3 times 1, -3 plus 7, 7 minus 3, 4. And don't forget, of course, the other one, -3 times 12,000, that will be 36,000. This is negative, 167, that would be 131,000. And we are done so far. Our goal is done, namely have 1 for A and the 0, 0 below. Now we need to work on the second level, which is having 1 here and 0 at the bottom. I'm going to keep it simple. I'm just going to flip these 2. I'm not going to do much, just flip R2 and exchange with R3. So my new matrix will be 1, 1, 1, 12,000. Maybe a bit out. Do it again. The new matrix will be 1, 1, 1, 12,000. Let's go ahead and flip these 2, 0, 1, 4, 31,000. And then I'm just checking to make sure I didn't do it right. 67, 36. And then the other one will be, just write it down, and then we'll just add it. We can just do it now. Step by step. 0, -1, 1, 4,000. Okay, so that's my new matrix. So now what we are going to do, since I already have the 1, 1, I need to get rid of this -1. So the only thing we need to do is to do R2 plus R3. We're just going to add these 2 so I can eliminate the -1. So let me just erase this. Remember, the first row is done, so we leave it as is. 12,000. The second row is complete as well. 1,431,000. So now we're going to add 1 plus the other. 0 plus 0, of course, is 0. 1 plus -1 is 0. 4 plus 1, we're adding 45. 31 plus 4,000, that would be 35,123,000. Yeah. And of course, the only thing we need to do now is to get 1 where the 5 is. So we just simply divide by 5. Or we multiply by 1/5, doesn't matter. So it will be 1/5 times R3. And let's see what we have, whatever we are done. So now we have 12,000, 0, 1, 4, 31,000, 0, 0, 1, 35, that'll be 7,000. And we are done. Notice, folks, that as this is what we wanted, just to have 1 in the diagonal and zeros behind the diagonal. Now we can go ahead and reconstruct the answers with this result. Okay, so this is our final result. Let me erase that. Always recall, folks, that the first column represents the variable A, second column variable B, third column variable C. So what does it mean? That C equals 7,000. That's what we have. So now we work backwards. So we know that C, which is the first one, this means 1C equals 7,000. So C equals 7,000. Going bottoms up, we know that 0A plus 1B plus 4C equals 31,000. So we have B plus 4 times C equals 31,000. But how much is C? Let me do it step by step. Sorry about that. So the second equation, we know that 0A plus 1B plus 4C equals 31,000. However, in other words, we have B plus 4 times whatever equals 31,000. We know what's the value of C, which is 7,000. So this is what we have. B plus 4 times 7, that's 28,000 equals 31,000. We subtract, so B equals 31 minus 28, 3,000. We already have the value of C, the value of B, and now we work the next equation up from bottom. So we know that 1A plus 1B plus 1C equals 12K. But we know the values of A and B, so we can find, say the value of C and B, so we can find A. Of course, we know that the whole investment was 12K. We invested 7, 3, that's 10. So this one has to be, of course, 2,000. But anyway, so what do we have? 1A plus 1B plus 1C equals 12,000. A plus 3,000 plus 7,000 equals 12,000. A plus 7 times 3, that will be 10,000 equals 12K. We subtract 10, so A equals 12 minus 10, 2,000. That's it. That's how we solve this system equation using matrix. But what we save is not carrying all the variables. We just simply work with the coefficients until we get 1, 1, 1 on the diagonal and zeros under the diagonal. Hopefully this helped, and we'll go from there. So we can answer the question actually, how much money did John invest in each type of funds? Of course, he invested 2,000 in the money market at 3%. He invested 3,000 in municipal funds at 4%. And last but not least, he invested 7K in mutual funds with a yield of 7% annual. And that's the answer. Thank you. Let's try this other example. X minus 3y plus z equals 4, negative x plus 2y minus 5z equals 3, 5x minus 13y plus 13z equals 8. Let's go ahead and use matrices. So let's extract the coefficients. That will be 1, negative 3, 1. That's the first row. I'm limited to 4. Negative 1, 2, negative 5, 3, 5, negative 13, positive 13, and 8. Okay. So remember, folks, 1 here and zeros in these other two positions. So let's go ahead and move over the first row. Now, since I want 1 here, 0, the only thing I need to do is just to take R1 plus R2, just add the two of them. 1 plus negative 1, that is 0. Negative 3 plus 2, that's negative 1. This plus that, negative 4. That will be 7. 4 plus 3 is 7. Now, the second step, I must get 0 here. So this is what we're going to do. We're going to take the first row, multiplying by negative 5, and add it to row number 3. So we are going to multiply this guy by negative 5 and add it to number 3. Negative 5 times 1, negative 5 plus 5, 0. Negative 5 times negative 3, 15 plus negative 13, that will be 2, 15 minus 13. Negative 5 times that, negative 5 plus 13, that will be 8. Negative 5 times 4, negative 20, plus 12, plus 8, negative 12. Okay, so this is my next matrix. Notice that I have my 1 here and a bunch of zeros behind it. Okay, that means that we are done with the first row. So let's go ahead and rewrite it. What I'm going to do, I'm going to change the sign here, multiply by negative 1. So I already have a 1. That will be easy. So I'll be 0, 1, 4, negative 7. Just change sign. And let me just be proper and write this one here, so we don't mix and match things. Okay, so now I need 1 here. I'm sorry, I need 0. I already have the 1 and the 1. I need 0 instead of the 2. Okay, so we're just going to first write the first. We're done with the first row. So 1, negative 3, 1, 4. We are done with the second row with the 1 here for y. So it'll be 0, 1, 4, negative 7. Yeah, the 0 here. I must get 0 here. How do I get the 0? Well, we need negative 2. So I'm going to take row number 2, multiply by negative 2 times row number 2. Okay. We're going to take row number 2, multiply by negative 2, and add it to row 3. In other words, multiply by negative 2 and add it to this puppy. 0, 0. This times that negative 2 plus 2, that's 0. Negative 2 times 4, negative 8 plus 8, that will be 0. Negative 2 times negative 7, that's positive 14, minus 12, 2. And we are done, because what happens here? Oops, my z eliminated. And my z, and worse than that, 0 equals 2. So we got here that 0 equals 2, which of course is false. So this puppy is inconsistent or no solution. That's it. So when the variables disappear and you get a false statement, just like before, no solution.